Welcome to another video. In this video we're going to see about Fourier Transform. Okay, so before we begin, as usual, there are some stuff you need to know. First of all, the stuff that you need to know is WO is equals to 2 pi over T. Okay, this is the first thing that you need to know. And then the second thing that you need to know is sine, cos, negative sine, negative cos. So this way is differentiation and this way is integration. Okay, so if you're integrating cos, it will become sine. If you're integrating sine, it will become negative cos. So sine, cos, negative sine, negative cos. Now there are certain stuff that you need to remember in addition with some stuff that you need to know. Okay, first, what is T? So T is, if you notice here, the maybe where we will take 1 as our point. So from 1, you see this is one wave, a cycle. So T is equivalent to 1 cycle. In this case we are starting here and it's ending here, so this is a cycle. Okay, so T is how many it takes for a cycle, so in this case it's 2. Okay, and then we have the partial fraction partial derivative, but I think this would be easier. Okay, so you have T cos nwt dt, so you need to integrate this. Okay, you need to integrate this. The easiest way is, first you write T nw. Okay, now if you integrate cos, it would become sine. So sine, then you write back everything, okay, until there, then plus 1 by nw square. So this is squared. Okay, now you just write back the whole equation. So this is your integration by part, sorry, not partial fraction. Then you have T sine nwt dt. So if you integrate sine, you'll get negative cos. So negative T nw cos nwt plus by 1, it's just the same. In this case we use the sine back. Okay, this is something you need to know. Now another thing is, we have a0, an and bn. These values supposedly sometimes becomes 0. So how to identify it? Now we have we have y and we have x. So for now we will focus on y axis. Now we have y axis, then maybe our graph is as such. Okay, this graph is actually a reflection on the y-axis. So if it's a reflection on the y-axis, the bn should be 0. Okay, if it's in the reflection of y-axis, the bn should be 0. So you just write it as y. Alright, now if we have a graph in the x-axis, now if the graph is totally above the x-axis, it's normal. Okay, but if the graph is as such, it has the upper part and it has the lower part, it cancel out each. So our a naught is equivalent to 0. Okay, so this is equivalent to x. Now we have an. So what is an? Now we have a graph. Okay, maybe this graph is as such. Okay, now in this particular region, if I circulate it maybe around, okay, not as such, Okay, in this graph, if I circulate it for 180 degree, if the graph looks same, then our an is equivalent to 0. In this case, 180 degree, it still looks the same. Does it look the same? Somehow, yeah, it does look the same. So it means that our an is 0. Okay, so x plus y, meaning that x axis should be up down, meaning that you can rotate it to 360 degree, meaning that in the y it looks like a reflection, so it would be 0. Now there is a example question for us to look. Now we are given these two graphs and we need to determine both of them. Okay, so we have a naught an and also bn. For this graph we have a naught an also bn. Now for a naught, okay, if we rotate this 360 degree, does it look same? No, so it's not 0. Now if a0 means up and down, a0 means x, so is it up and down cancelling? Yes, so it's 0. An, you need to rotate it 360, so we can't, it's not 0. Bn, what does bn? Does it reflect on the y axis? It looks the same, so it's 0. Now for this graph, AO, is it up and down? Yes, so it's 0. AN, if we rotate it 360 degree, does it look same? Yes. Now BN, is it a reflection on the y-axis? No, so it's not 0. Okay, this is a simpler method where you no need to do all this separate stuff. You are just entitled to do what is not 0. Maybe for this graph, if they ask you to calculate, you no need to go and find an, you no need to do this stuff and waste your time. You just need to do a0 and bn. Okay, now we have a sample questions on circuit and also the graph, so it would be easier. Okay, now we need to do the Fourier series for this graph. As said, first and foremost we need to find our t. Now the t is, it starts here, it ends here, it starts here, it ends here, so the t is 1. Okay, now the second thing that we need to know is wo is equivalent to 2 pi over t. So 2 pi over 1 is equivalent to 2 pi. And then we need to find our function. In this case our function is y equals to mx plus c. So our c, we know that it's in the 10. C means where it's crossing in the y-axis. Okay, now m, how to find the m? So this is the first point, this is the second point, so meaning the second point of ours is 0 minus 10. Now the second point is 1, the first point is 0, so this would give us negative 10. So our function here is negative 10, x is our t now, so t plus by 10 is our c. So this is our function. So this function is the function for the graph, right? So wo was 2 pi. Now let us do a0 first. So this is the formula for a0. I don't want to write it back, so I'm gonna skip that step. You can refer back above. Okay, now a0 is equivalent to 1 over 1 integrated or 1 or 0 negative 10t plus 10 dt. So 1 over 1 is 1, you can cancel out there. So if you integrate this, you will get 10t power of 2 over 2 plus by 10, and the input value is 1 and 0. So you just need to input 1. Okay, so this, if you simplify it, it would become as such, and if you input 1, the final answer would be 5. Okay, now our a0 has been found. Now let us do for an. As said, an's formula is this. I'm not going to write it back. So 2 over t, which is 1, so our function, then it's cos 2 pi n t dt. Now if you look closely, okay, I'm gonna write it back so I can explain it more further. If you look closely, these are two functions. I mean, you can make it as two integration, okay, the plus here and the plus here. Now negative 10, you remove it times by 2, okay, it would become as 2 1 0 negative 10 cos and so on. So this 10 would become as negative 20 cos and so on. Okay, so I'm gonna save some time with this stuff writing it. So if we write it, so we will get it as such. Now sine 2 pi is equivalent to 0. Okay, sine 2 pi is equivalent to 0, so automatically we will get 0 here. Now here we will be getting sine and also cos. Now cos 1 is 1 and cos 0 is 1 too, so eventually here we will be getting 1 minus 1, so technically the total value would be 0. Okay, so now you need to know the identity where sine 2 pi or sine of any full stuff would be 0. Okay, so cos 2 pi would be 1, so 1 minus 1 would end up into 1. So you need to know the identity of that, or you can take your calculator and calculate it. So the end answer would be 0. Okay, so Bn, in this case we couldn't have identified that an is 0 because we didn't have the graph function here, so we can't assume if we rotate it 360 it would be 0. Okay, now Bn, we write Bn is here, so we write the formula. Okay, we are skipping to write the formula. I'll write the numerics. As said, you can simplify it, as if you simplify it you would get as such. Okay, now you have your Bn. Now as said, sine, if you integrate it will become cos. Okay, so that cos will end up to 0. Okay, now the only thing that's remaining is this, so we're gonna bring it down, so this would be automatically become 0, so we can ignore it. Now negative 20, if you remember just now I have given the simplification of that. Okay, so we're just gonna copy the numeric, so negative t, it's NWO, so our WO is 2 pi, so it's gonna be 2 pi n cos 2 pi nt plus by 1, and we notice that here we are doing the square, so if we are doing the square 2 pi n would become 4 pi square and square sine 2 pi nt, so 1 to 0. Now sine 1 would become 0. Okay, so it will be automatically be 0, and here everything would be 0 too. Now the balance would be negative 20, then negative 1 2 and pi. Okay, so if we calculate it we will get 20 over 2 and pi, and the answer would become 10 and pi. So this is our Bn. So when we write our final equation, So the final equation is as in this format. If we write it, our A naught was 5 plus by the sum is 10 n pi sine 2 n pi t. Okay, so now this is for the Fourier transform for the graph. Now look at the question here. Expression from figure 3.1, which is for Vs, then the circuit shows 3.2. Now we need to find the current before we continue. Okay, so now S is JW as said in the previous lecture. Now we have the certain number, so 5 become 5, 1 Henry becomes S, 100 microfarad becomes 0.1 farad, which is automatically becomes 1 over 0.1 S, which is 10 over S. Now we are going to find current. So V equals IR, I equals V over R. So Vs is given, I we are going to find, R is the Z total of this circuit. So in order to find the Z total, we are going to sum up. So if we are summing up 5 plus by S plus by 10 over S. So this is how we sum up. Now we are going to find DC component. Now what is DC component? In a equation, anything that's before the summing is DC, and anything that's after the summing is called as harmonic, AC harmonic. Okay, so anything that's before the sum is DC, and anything that's after the sum is AC harmonic, because here it's not changing due to anything, but here the n pi, the n will change. Okay, now DC, we're going to find the DC component. Now due to we having S, we make it as, okay, so S should be 0. Now ZS is equivalent to 5 plus S plus 10 over S. Due to finding DC, we are going to make every S as 0. Now when we are making this, we notice that 10 over 0 will reflect to infinity. Okay, if it's doing as such, our current would become as 0. In this case, if there's no, if is it such, we will get 5. Okay, so if we get 5, then our DC was 5 and our Z was 5. So we know that I is equal to V over R. 5 over 5 would give us 1. So our IDC would have become 1. So in this case, we had 10 over S and it became 10 over 0, which is infinity. So infinity is 0. So IDC is 0. Okay, now we're going to find the AC. Now here we need to be very careful. S is equivalent to JWN, and our W is given that it's 2 pi. So it would become as J 2 pi n. Alright, now Z, our S is now J 2 pi n. So equivalent to 5, just replace every S with the value given. Okay, it's J2. Now here if you notice, it's actually 1 over J times by 10 over 2 n pi. So 1 over J is equivalent to negative J. Okay, so 1 over J is equivalent to negative J. Remember that. Now this equation could be simplified to this, form. Alright, now if we do the calculation correctly, we will get in this form. So technically you are grouping the imaginary apart and the real apart. Now we are going to find the magnitude first. So finding magnitude is equivalent to square root of real power 2 by imaginary power 2, which is equal to real here is 5. So square root of 5 square which will result in 25 plus by the imaginary is this. So we have grouped the imaginary. You're just gonna write everything in the bracket by square 2. Now we're gonna find the phase. So the phase is equivalent to tangent negative 1 imaginary by real. Okay, so tangent negative 1, the imaginary parts are given as 2 pi n minus 5 and pi over 5. Okay, we have got our two stuff. Now how do we write it? Now we're going to say that we are going to write IOT, right? So the DC harmonic, we didn't get anything, so we're just going to leave it. Okay, so we get it 0, so 0 doesn't make any sense here. Now AC harmonic, we have magnitude. Before that, we're going to write this 10. Okay, the 10 is the amplitude. Now here is the n pi, so our magnitude is going to be written down beside this n pi, and then square root, we're going to write everything that's in the square root that has been found for the magnitude. Then sine, we're going to do a bracket, we're going to write this 2n pi t minus by the phase. So you're gonna close the bracket, and due to current you're gonna put A. So here you could have put in V, but you already mentioned, so you don't need to put here. It's just for namesake. Now this is how you solve it. Okay, thank you.